Okay, here is the geometry homework that you had, and I'm going to go over a good bit of this, so if you happen to watch this video, it's going to be a good thing for you. So let's look at a couple of these problems. Alright, looking at number 1. You have, let's see, it tells you that F is parallel to S. Alright, here are your movie seats here. But that really doesn't matter. We know F is parallel to S. That means that this angle that you have here, this angle that you have here would be alternate interior angles, which means they're equal to one another. So it tells you here, measure of angle 1 is 68, and the one in green that I just wrote over that you can't see anymore is 4x. So we're going to have 4x is equal to 68. If you divide both sides by 4, you get x is equal to 17. Alright, looking at number 2. Again, we have roads A and B that are parallel. So A and B would be these roads, this one and this one. And we have roads that are going through. So if you have this line here, right? You now have angles that are going to be alternate exterior angles. So if they're alternate exterior angles, we have 2x minus 22 equals x plus 40. Alright, I'm not going to go through and solve that. You should be able to solve that. But the key is that this angle and this angle are alternate exterior, which makes them congruent or equal. So you can set them equal to one another and solve for x. You should be able to do that. Let's do the next one. Hold on one second, be right back. Alright, looking at number 3, you have these two lines being parallel, and you have this line cutting through, which is parallel, and all of these angles are going to be corresponding, because all of these bars are all these lines are all parallel. Alright, so that means the ones in red are going to be congruent. So you can say that 12x plus 2y equals 126. That's because they're corresponding. Then you can say that 3x plus 2y is equal to 36. And you can say that because this angle, and I'll put it in blue, this angle and this angle are alternate interior, which makes them congruent. Alright, so think about that for a second. Alright, I'm back, and I had not put the 6 here, so this 6 was not there before, it is there now. Now, what you have here is two equations with two variables. Little bit of review from last year. This is a system of two equations. The only way you can solve this is by a couple of different methods. You could use substitution, or you could use what we call elimination. So what we can do is multiply this bottom equation by -1, and we can keep the first equation, and we're going to have 12x plus 2y is equal to 126. The bottom one will be -3x minus 2y is equal to -36. Now we're going to end up with, we're going to add these together. Again, this is called elimination. Cancel out. This is going to be 9x is equal to 90. This is 126 plus a -36 gives us 90. And we end up with x is equal to 10. That's our value for x. Now, since we know x, now we can come back in and plug for y. So I can plug in either one of these equations. I can plug in there, or I can plug in here. I'm going to use the bottom one since it's got lower numbers. So we can do 3 times 10 plus 2y is equal to 36. And 30 plus 2y is equal to 36. Subtract 30. Subtract 30. You end up with 2y is equal to 6. Divide by 2, divide by 2, and you get y is equal to 3. So those are my two values, x equals 10 and x equals 3. So that was for number 3. So we'll go ahead and erase this. That was a little bit more challenging, a little bit of review from last year, but a good problem nonetheless. Okay, I'm looking at number 4. Now, what I've done on number 4 is I've actually put lines because the given information is that AG and CJ are parallel, which is this part here, and I put those lines both in red. And AD and FJ are parallel, and I put those lines both in blue. So they're asking you which is a true statement about DCJ. When I put DCJ here in green, that's this angle right here. And there's another green angle I did, because we know that that one up there is 50. Now, it might not be apparent looking at it the way it is, but if I took my diagram and then I twisted it around, looked at it this way, we could know that D would be our answer, because DCJ, which would be this one, angle DCJ, and this other green one up here, this one, they are corresponding, which means they are congruent. So that is our answer for that one, D. Okay, on the back side, if you have your notes, we have talked about this at length, but if we look at this diagram, corresponding angles, you've got to think of it this way. If I could cut these two, if I could cut this figure right here, and if I could take this bottom figure, which would be this one, and physically move it up to the top, where would all these numbers land? Those are your corresponding angles. So I'll give you one set. Angle 1 is congruent to angle 5. Now you can probably, hopefully, do the rest. We've talked about also alternate interior. Again, we can look here, angle 3 and angle 5. They are inside of our parallel lines. These are our two parallel lines, and they're on the alternate or opposite side of that line that's cutting through. So we have angle 3 is congruent to angle 5 because they are alternate interior. Same side interior, or what? No, I'm sorry. Alternate exterior. You should be able to do those. Those are on the outside. So if you have 1, that's on the outside of parallel lines. Then on the opposite side, on the outside, is 7. That's another one. So angle 1 and angle 7. And same side interior. So the same side interior would be on the same side on the inside. 6 and 3. Same side inside. All right, hopefully that helped you out with the work, and hopefully you finish the rest.